magnesium with the bromobenzene to form the phenyl magnesium bromide, that will boil the ether, and we'll actually see it kind of go to a gray, cloudy solution as it does that. So I don't need to heat this yet. I'm hoping that just the heat generated by the addition will get it to start refluxing, and then after the addition is complete, then I'll turn on the heat so that it refluxes properly. So I'm just going to add a few drops off the tip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops or so. And then I'm going to stir that pretty vigorously at about 600 to try to get the magnesium really moving, and watch and hope that the reaction starts spontaneously. While I'm waiting, I'm going to grab a medium-sized spatula and kind of scoop that sand so that it's touching the walls of the flask, so that I'll get good contact when I do turn on the stir plate. And I can also return some of these reagents to their location. Benzene and the iodine. It's sometimes productive to stir the magnesium overnight under an atmosphere of argon to break up some of that oxide coating, and then, since there's argon present, it prevents it from reforming when it hits the atmosphere. Take this and throw it in the trash. If the reaction doesn't seem to want to start, you can also reach in there with a glass stirring rod and smack on the magnesium a little bit. That one should fit. It's not really science getting a Grignard reaction to start, it's more magic. I may use a 1 milliliter syringe to measure this out as well, since 2.27 milliliters is going to be hard to get exact in the graduated cylinder. Although it's not critical that it be exactly 2.27. Since that one is actually the limiting reagent, we do want to be fairly close. I'm going to crank that all the way up to maximum speed. Try to get that magnesium really rolling. And I'm going to add another 5 drops. Yeah, maybe 7 drops. Tighten that up a little. Once it takes off, it usually takes off pretty quickly. The challenge is getting the reaction to start. What we don't want to do is add the bromobenzene too quickly, because there's a side reaction that takes place here where the bromobenzene can react with phenyl magnesium bromide. So if we actually have phenyl magnesium bromide present, since it's a strong base, it can actually deprotonate bromobenzene. So phenyl magnesium bromide can act as a base to take that hydrogen off, and it will actually do an elimination reaction, a syn elimination, to form a triple bond there. And that triple bond is a little weird because normally an alkyne would be linear, but in this case the alkyne can't possibly be linear because it's trapped in a six-membered ring. This is called benzene, and it's very reactive. So reactive, in fact, that it can be attacked by nucleophiles, where normally a triple bond is not attacked by nucleophiles, to generate an anion and form a new carbon-carbon bond between two benzene rings. This can then get protonated from the ammonium chloride in the workup to form a compound called biphenyl, which is two benzene rings linked by a carbon-carbon bond. And biphenyl has a molecular weight of 154, so 77 for each benzene ring. So we may well, if we add the bromobenzene too quickly, have a case where the phenyl magnesium bromide is going to find bromobenzene before the bromobenzene finds magnesium and get this side reaction. We'll almost certainly see some biphenyl product. We want to make sure we don't see too much, because you'll notice it actually consumes 3 of our benzene rings, 1 to take the proton off, 1 for the bromobenzene, and then 1 for the phenyl magnesium bromide. So 2 rings are going in here, but you're also wasting it. So you're wasting 3 moles of bromobenzene for each mole of biphenyl that's produced. We'd like to keep that side reaction to a minimum. And that reaction is one that you'll study later in chapter, well, in my textbook. I believe that's in chapter 22, maybe? The same chapter as the phenols. Not sure where it is in Klein. So that's why we're not just adding all the bromobenzene all at once. So the reaction doesn't seem to be starting. So what I'm going to do is I'm going to take off the separatory funnel, and I'm going to go in there with a glass stirring rod and just kind of bang on the magnesium carefully. I don't want to bang on the magnesium so much that I poke a hole in the bottom of the flask. But really all I'm trying to do is cut off some of that oxide coating to expose some fresh surface of magnesium, which was the purpose of the grinding in the mortar and pestle, but it oxidizes so readily in air that maybe I didn't get it in there fast enough. And we'll crank that back up and see if that does the trick. And sometimes one has to heat it a little bit, get the reaction to go. I don't want to heat it too much because it will generate some heat of its own, but it wouldn't hurt for me to crank that up to about 50, just kind of warm the ether solution. Try a little bit of everything. If all goes well, the majority of that magnesium will be consumed. There's a little bit of excess magnesium, which is why I was wanting to err on the side of a little too little, a little bit below 0.47 grams instead of a little bit more than 0.47 grams, so we don't have too much excess magnesium to get rid of at the end. Any excess phenyl magnesium bromide, when we add the ammonium chloride, will just react to form benzene, which rotovaps off. So I'm going to give that a little time to heat and stir and hopefully start. And while that's doing that, I'm going to go ahead and set up a rotovap. It looks like this one was allowed to go all the way dry. It looks like that wasn't emptied. It looks like that was just allowed to boil dry. That's unfortunate, because now we got a bunch of crust in there. And just to fill that up, I'm going to grab some ice. Take a look at this reaction. Yeah, it's not really doing much. Looks relatively unchanged. So we're just filling that up to about the top of the pump motor housing. And we're going to fill this guy up. Over the tips of the metal there. So when we turn it on, it doesn't go too out of control. And I'm going to add some water. I'm going to wipe that out with a sponge as well. Get rid of some of that salt crust. Add a little bit of water first. Doesn't look like this thing was treated very well last semester. Look. It almost looks like it's gone a little less orange. We'll see if that continues. That should be enough water in there. Looks like this water hasn't been used in a while because it's kind of orange. No point having a filthy rotovap. A little better. fill that guy up to about 1 inch from the top. So it'll be ready to go when we need it. Water's definitely coming out a little orange. Must be a boil advisory. Or maybe don't drink the water in the lab advisory. It's a good level. And that orange, that water is really colored. We'll fill that up. That's going to be running cooling water through the condenser coils. And we're going to fill up the pump so we can achieve a better vacuum. Cool that off.